Hi guys, we're going to look at the solubility of gases today, so I have a demo for you. I have a Fisher burner here. A Fisher burner is similar to a Bunsen burner, except it's a little bit wider. And I have a big copper rod that I'm heating. I'm going to heat it for a minute or two so that it's very, very hot. And I have a 2-liter Coke bottle here. It's about at room temperature right now. So I'm going to heat this copper rod for a couple of minutes, or a minute, and we're going to open this and I'll put it in there and see how, when it gets hot, how that affects the solubility of the gas inside. So soda is made up of mostly water and obviously carbon dioxide, which is a gas. And so we're going to look at the solubility of the carbon dioxide. Okay, hopefully it's hot enough. I'm going to go ahead and open my Coke bottle. I'm going to put the hot copper rod in there. And we can see that a lot of the carbonation came out of the solution. So that tells us that solubility of a gas decreases when we increase the temperature. And we had looked at that when we looked at our solubility curves here. So we said ammonia is a gas, and the solubility decreases here as the temperature increases. Something else that affects the solubility of a gas is pressure. So pressure really only affects gases. It doesn't really affect liquids or solids that much, but it does affect gases. And as you increase the pressure, the solubility of a gas increases as well. That's why when they make soda, they pack it under lots of pressure. So when you open your soda bottle, you hear like that hissing sound. That's the pressure equilibrating. Some of the gases are leaving your soda to come out so that the pressure outside and inside would equal to each other. So if you were to open a soda bottle and take a sip right away versus if you leave it open for a while and then take a sip of soda, you'll find that it has more carbonation when it's first opened because it was packed under a lot of pressure. So as the pressure increases, the solubility of gases increase as well. And that's called Henry's law. So let's do an example. It says the solubility of nitrogen gas at 1.75 atm is 32.6 grams of the nitrogen per 100 grams of water. What is its solubility if the pressure is increased to 4.37 atm? So because it's a direct relationship, we're going to say S1 over P1 is equal to S2 over P2. So the solubility is 32.6 grams for every 100 grams of water when the pressure is 1.75 atm. What would it be under 4.37 atm? So to solve for S2, you would take 4.37 times 32.6 divided by 1.75. That gives me 81.4 grams of nitrogen, and this is for every 100 grams of water.